Hello everyone, my name is Pattanon Soponwichettawong, and today I would like to do the presentation about computer networks on network topologies. So what I will cover, so it will be like this. So the first one I will cover is, the first is the foundation, next is the six topologies, and the third or the last is the synthesis. So here we go. So how the topology shapes the network behavior. So there are two dimensions of every network. Is the physical layout, or how the device connects, and the logical flow, or how the data moves. Together, they determine the performance, reliability, and scalability. So first we'll go with the physical topology. So it's a tangible infrastructure, like cable ports, device, and it defines which nodes are directly wired and sets the hard limits on signal paths and the fault zones. The next is the logical topology. So it's the behavioral layout. So how the data packets into address, routed, delivered, and physical wiring and the logical flow often differ. And it gives a network a flexibility beyond the cables. And about a six topology and a six trade-offs. There's bus topology, star topology, ring topology, mesh topology, tree topology, and hybrid topology. So each balance these two dimensions differently. So it's produced at different distinct cost, reliability, scale, and scalability profiles. So six topologies and six trade-offs. So the good thing is it has a lower cost. There's the one with lower cost first, and simple structure. So the bus topology, it has a backbone cables that connects all the device, and it's the cheapest of all, and highest single point risk. The next is the star topology, a central switch linked into every node and easy to manage and widely developed. The last of the low-cost one is ring topology. A device is chained into the closed loop, equal access, but one break disrupts the cable. So I will go into the higher and expensive ones. Okay, so it has a higher cost and stronger resilience. Mesh topology, every device connects into every other, maximum fault tolerance at maximum expense. Next is the tree topology. It's basically tree starburst, a tree hierarchy built for length, expanding, and campuses. And hybrid is two or more topologies combined, flexible and highly reliable, and it's kind of complex to manage. So first I want to begin with the bus topology. The bus topology mostly relies on one backbone, so like a single cable that carries all the traffic, and every device connects to one shared backbone cables, and the data travels to the full cable length to reach its destination, and minimal cabling and fewest material of any topology. And it has a low cost that suits all the network. Installation is fast with no central devices required, practical when connecting with a lot of handful device in a close range, and lowest hardware to spend on any standard topology. And one break full network down. Because it has only one system, so if a backbone failure serves a connectivity for every concentrated device, there will be a no redundant path to exist on this routed data, and cost advantage disappears when reliability is required. Next is star topology. The star topology is centralized to a switch, so all devices are connected to one switch that is easy to maintain, reliable, and most widely used topology. Connection will be a central switch. The maintenance would be a fault and isolated per device. Cost is kind of medium, and reliability is kind of high. And the weak point is it has a central switch, so if it fails, all the access rule doesn't work. And it's the most widely used topology. Next is the ring topology. It has a circular data distribution, so each device connects exactly to two neighbors, forming a closed loop. Data travels hop by hop around the circle until it reaches a destination. And collision risk stays low, and only one device transmit at a time. And it has equal access for every device, so no central switch to favor the bottleneck of any node. So every devices get the same turn to transmit. Access is inherently fair, and token rings networks using its principle to manage orderly traffic. But the problem is one failure breaks all the circle. So a single device or cable fault can interrupt entire network. And fault isolation is harder than a star because it has a no central hub. So this fragility makes a ring topology rare in modern deployments. Okay, let's see the tree scale hierarchy. So fault tree and bus topology merge into a branching hierarchy. So a group of stars connect the device, feed which share a backbone, and adding branch, meaning attaching to a switch and no rewiring required. So a trade-off of backbone failure can cascade multiple branches simultaneously, unlike a star, where only the failed device goes offline. Next, hybrid blends a multiple topologies for a higher resilience. So hybrid topologies blend multiple topologies. It's flexible by design. It combines two or more topologies into one network. Star bus and star ring topologies are the most common pairings, and each network segment uses the structure that fits the role. And very high reliability. No single topology failures can take down the whole network. The fault isolation is built into the blended structure, and preferred by large enterprises and multinational organizations. The cost and complexity rise. It's managing topology demands like more than a skilled staff. Its required infrastructure investment is kind of high, and the right choice when no single topology meets every demand. Okay. So for the star network topology that leads for everyday network, and most networks do not need this kind of military-grade mesh or enterprise complexity. A star topology delivers a practical ground, medium cost, and high reliability, and its straightforward troubleshooting. Mesh and hybrid topologies offers more fault tolerance, but price and management burden feel deployment justified. So to match a topology to the requirement for a star is for offices and classrooms, trees for large campuses, mesh is where only failure is not an option. So in conclusion, star topology is good for offices, everyday classrooms, and deployments. It has a medium cost and has a good, very high reliability. The tree topology is good for large campuses and expanding hierarchy. It has a medium cost and good scalability. And mesh topology is for critical infrastructure, zero downtime systems. It has a high cost and very high reliability. So that's it for my presentation on computer networks about different types of topologies. I hope you enjoyed my presentation. Thank you.